That's great, Steph. Thanks so much. Welcome, everybody, to the Drones in the Coastal Zone, our regional workshop for applications of uncrewed air systems in the Southeast and U.S. Caribbean. I'm going to turn on my web camera here to make sure that that's working right. Click a few other buttons. I just want to let everybody know that we're recording this session, and we're recording it so that we're able to provide these recordings and the supporting documents. And those will be made available on the workshop website soon after we're completed with this workshop. I'm Chris Taylor. I'm an ecologist with NOAA's National Centers for Coastal Ocean Science. I'm a member of the technical team that's bringing you this virtual workshop. We began planning this workshop about a year ago and intended to host you, our friends and colleagues in Beaufort, North Carolina, last April. We tried again to reschedule and host you in person in October. And obviously that didn't work, so we are very excited to host you in a virtual workshop. And we think this is a great way for us to meet even more of you and learn about your needs and applications of drones across the Southeast and Caribbean. You are experts in drone practitioners, you are coastal managers, and we hope to learn from you about your needs in coastal management and those challenges and where drones might fit in. Again, we're excited to present this workshop in a virtual format because it allows us to present a variety of materials, both synchronous materials like the in-person or the virtual workshops that you're attending now, as well as asynchronous videos and background material that will be shared with you from Abby Wakely, one of our core presenters. But to kick off this workshop series, I'm honored to introduce Admiral Timothy Gallaudet, who will be providing some opening remarks. Admiral Gallaudet is the Assistant Secretary of Commerce for Oceans and Atmosphere and the Deputy Administrator for the National Oceanic and Atmospheric Administration. Before coming to NOAA in 2017, he served 32 years in the U.S. Navy, retiring as their Chief Oceanographer. Now in NOAA, he leads NOAA's Blue Economy directives in marine transportation, sustainable seafood, ocean exploration, marine tourism and recreation, and coastal resilience. He also leads executing NOAA's science technology strategies in artificial intelligence, the omics, cloud computing, citizen science, and what he'll speak to you about today, advancing uncrewed systems to meet our many coastal and ocean management challenges. Admiral Gallaudet, thanks again for taking the time to speak with us today.
Hey, Chris, thanks for that kind introduction. It's great to be here. And, I would rather meet in person, as everyone here would like to, but, let me just state that despite this pandemic, I have to really just applaud our people and our partners for not slowing down. And this workshop is just a terrific example. I mean, I think a year ago, if you had been told that you wouldn't be able to do this in person, you would have probably just thought of canceling it. But that's not the way we are. We're committed to our mission. We're passionate about it. And that is what I just love about working with this agency and has made every day for me an absolute delight. So a little bit about this, our drones in the coastal zone. Actually, I'm not going to say anything about it. I'm going to ask a question, Chris. Who came up with that terrific name?
Sir, that was a combination of Dave Johnston and myself as we were sailing back from the Antarctic across the Drake's Passage. Had a little bit of time to get creative.
Very good story, too. And well, thank you, Chris, and I applaud your leadership in this area. And Dave, thank you for running the whole show behind the scenes. And Steph, I appreciate what you're doing, as well as Whitney Jenkins. I see you both have pretty major roles throughout the next few days. So thanks for putting this on, as well as our partners with Socorro, with the National Estuarine Research Reserve System, and IUSE, of course, all helping make this happen, along with the Office of Coastal Management and NCOS. So if you could advance the slide, please. I think, as you mentioned, Chris, this uncrewed system activity of ours is part of a larger S&T picture. And what happened is, it was probably maybe a year and a half ago, where UXS, I'll call it, was first taking, off in terms of getting formally supported through a new program. And I looked at some other areas at NOAA that we were doing as an agency, all out in the field, really. And it was these 6 areas that were just rapidly advancing. And it kind of came to me from my experience that the best way to coordinate cross-agency activity and partnerships with external entities would be formalizing, our way ahead through strategy documents. And I have some experience from the Navy in doing these, and I think they're really good to do because if you look at each of them, they're fairly well aligned in the things they want to accomplish. So it's about advancing the workforce through training, which I'll talk about. It's about reorganization and some changes we've made to better adapt to advance these, and some other efforts about conducting research and accelerating the transition of research to operations. So all of them have that in a bit, and they all are interconnected in a really fantastic way, and in such a way that we've at NOAA headquarters, under the NOAA Research Council, we've stood up a new S&T committee where the team leads for all of these efforts meet regularly to talk about the synergies and ensure each is mutually supporting the other. I mean, they're all critically dependent upon data, and so there's that interconnection. And then there's others that aren't so obvious, but I can talk to. But it's a pretty exciting time for our agency because each of these documents are signed by every assistant administrator, as well as myself and Dr. Jacobs. And so there's institutional commitment to move forward. You know, it's neat that we're moving out on this and showing great leadership as an agency. And they're also, we picked these because they're transformational in nature. When you look at UXS specifically, and we're going to talk about these 5 attributes, I believe, of why we are using these systems in the first place, and it's because they are realizing incredible improvements in efficiency and performance. And that's what's key, is that we are actually advancing our ability to perform the mission and doing it at a reduced cost, which is, helps us just cover more territory and make a bigger impact. So wonderful things there. Now, but let's move forward and let's talk more about this workshop. And by the way, uncrewed systems is a relatively new term. Unmanned has been the sort of term of art in the industry and in the government, and it's still being used by and large. But I decided to make the change because I had seen so many fantastic women in our organization leading efforts in research and operations, and you can see pictures of them right here. And I thought, I saw that somebody in industry, I'm not sure, I think it was Fugro, adopted the term uncrewed, and I said, we're following suit. That's the right thing to do. And the response has been terrific. But regardless of the name, this is a snapshot of some of the activity we're undertaking here. And we've articulated it in the strategy document I mentioned. And in fact, I deliberately included in that document remotely operated vehicles, because that's an area we're also rapidly advancing in. And we have, a great experience. In fact, you, Chris, I told you I was going to give you a shout out, and I'm going to do it, is showing just a tremendous leadership and innovation in the world of ROVs from our NOAA ships and our partnerships. So, he did a really amazing job with that technology in characterizing the oil contamination from the Taylor spill. And that documentation was critical to get Coast Guard to respond and follow suit in other ways, specifically legal ways. So that was terrific. And then there's others like you see here. What's so awesome about this activity, it covers every NOAA mission area. So it's about environmental sensing and observation and prediction. It's about conservation of protected species and endangered species. It's about ecological monitoring, HAB forecasting, for example, coastal mapping, fishery surveys, everything. Really, and a terrific kind of testament to why uncrewed systems are just going to be increasingly used and dependent upon going forward was demonstrated just this last couple months. So here we are. We were in a pandemic. Our ships were not able to get underway. They are now, but we were pierside for a period of about 4 or 5 months. And in that situation, we were not collecting, critical data needs. And so with our UXS activity going on, we had some things in place to go fill some, critical gaps. One was the Alaska pollock fishery survey. That's a critical survey because that fishery is the largest in terms of economic value in the nation. And so to, ensure we manage that fishery properly in a sustainable way and not overfish the resource, we need to have data about how much fish are out there, abundance and biomass. And we've used these uncrewed surface vehicles, sail drone, to perform those surveys or augment them in the past. And they were the vehicles doing the survey this year. And we've proven through about 5 years of R&D and partnerships, the public-private partnership with Saildrone, that we could perform those studies just as well as a ship could. And so that's the way ahead. And then there's other activities too. We did a critical North Slope of Alaska mapping mission, and we also performed the hurricane glider observation network with IUS and Caracoos that was critical to forecasting the most historic hurricane season ever, with 10 landfalling hurricanes this year. And our accuracy was really unmatched. Not even the European model could match us in performance. And that resulted in evacuations and saved lives. I could go on, and I know I only have a few minutes. So next slide, please. So that's why we're moving forward. The great development here is we have in FY20 a new program. It's our Uncrewed Operations Center and a program line in OMAO. And so that's a headquarters, OMAO headquarters has now the program line for this. And it's a new start with $12 million. We actually, in the NOAA budget, only put forward $4 million because we just were really constrained by a number of other restrictions. And the appropriators in Congress liked it so much they gave us $12 million. So we're standing up this center. We're going to put people in it. They're going to be the central point of contact for acquisition and standards and things like that. Then under that operations center, we'll have a supporting air operations center at our aircraft operations center in Lakeland, as well as an uncrewed maritime systems center in Gulfport, Mississippi. And those will be the centers that conduct the training and certification and sort of jet out equipment and assets to the teams that need them out forward. So this is great. I mean, this is a transformational change in our agency. We've made organizational changes to follow, and this is just the way ahead. So it's really terrific that we were able to get both presidential budget support as well as congressional appropriations. So next slide, please. Now, good example of this occurred just recently, and we had a spring tornado outbreak that you can see depicted some of the damage there on the left, and then we've had some severe flooding, for example, because of the hurricanes all around the Gulf Coast. And so, and we've been using UASs to monitor and those activities and survey the damage. And this is very nascent right now. We're either working with partners in academia using their platforms. In some cases, we're able to obtain our own. But we haven't done much. And my vision, the whole purpose of this strategy and the follow-on implementation plan is to ensure every weather office has access to a UAS. They've been doing it in Alaska for a little bit. The WFO in Charleston has also, as well as WFO Blacksburg, Virginia. And the goal is really to get more of these out there so they can perform these critical functions. When a tornado or a hurricane, blows through a region, it is a dangerous place to be. And how much more smarter and safer is it to use, a drone for this activity? And I have actually firsthand example of this. Some of you might know I lost my house in Hurricane Katrina. I lived in South Diamond Head, and we saw the highest storm surge of any area in the country, 27.5 feet. The whole Bay of St. Louis went in our neighborhood, and we went there the day after, and it was like a war zone. I mean, first of all, there are no houses where my house was, but all our houses were washed up against I-10, and we had to climb over that lumber pile with wires, and it was not safe. We don't want to put our people in harm's way either, but we needed to perform these surveys. These assets can do it and do it well. So next slide, please. All right, now partnerships are a main part of all of these strategies. It's certainly the uncrewed piece, and I'm just really pleased that we've been able to show such tremendous results with really modest assets to date. We only have about 100 uncrewed systems of all types: gliders, UASs, and AUVs, for example, that NOAA owns. But we, in effect, probably have the equivalent of 300 to 500 with our partners. So we're talking about those that I named, like IUS, like academia, like Navy. And we've all signed agreements with these folks. In fact, moving forward, we had a big summit at the White House that NOAA was the main player in, that the Office of Science and Technology Policy hosted in November of 2019. And it was the Ocean S&T Partnership Summit. And the kind of follow-up from that was to embark on new partnerships to advance our mission. And we've done this with a number of philanthropic organizations, private sector entities, and government partners, state, local, and federal, to advance our mission. And we're doing that in a really big way for UXS, as well as ocean mapping and exploration, and fisheries management, and you name it. So it's very exciting development here. And Whitney, I know you're from North Carolina, DENR, and thanks for being here and just demonstrating the importance of these partnerships. Okay, next slide. I failed to mention that we have our regional collaboration team also here for the Southeast, and so really that's another great example of working together through a network of partners and NOAA offices to do more than what we could do alone. And interestingly, these pictures show UASs. One is that's Katie Sweeney from the Alaska Fisheries Science Center on the upper left, and then that's Dr. Heiss DeBoer from Ezrel and Ceres in Boulder. So this is not a southeast, no examples depicted here, but just sort of represented the fact that we have partners in our cooperative institutes, in our state environmental offices, and they're all helping us work together to advance the capability. My goal, okay, so for example, we conducted about 1,400 UAS sorties last year across all of NOAA. I'd like to see by, the 5-year end date of our implementation plan for this strategy to have like 10 times that, to have 15,000 sorties each year. I think that's totally in the art of the possible, and it will be possible through these partnership networks. Okay, next slide. So moving forward, a big part of advancing this is going to be through STEM education and outreach and training. Interestingly, this picture on the left is from one of these MATE robotics competitions. MATE is the Marine Advanced Technology and Education Consortium, and I had to include something underwater here in this presentation because I'm an oceanographer and that's sort of near and dear to my heart. But at any rate, that the work they do to foster STEM education and the next generation is work we really want to replicate across all the systems, so UAS and others. And the same, goes, you see a good example of some training being conducted on the right there. And we are undergoing, establishing and formalizing our training activities. AOC is doing that in Lakeland with our UAS, and we're working to expand it. I really like what we've done with UMSs in Gulfport. We've leveraged the University of Southern Mississippi's formal certification course, and we want to expand that in a big way because it's our workforce, our people that are going to be realizing, these awesome advances. Okay, well, next slide. So, wrapping up, I have to applaud our team at NCOS for completing this technical document here about doing shallow water mapping with UASs. I've met Tim Batista and Brian Costa before. I don't think I've met the other authors, but it's just great work here. The structured from motion work to derive and extract bathymetry from imagery is just a great cutting edge capability. And when you think about what we can do with that in terms of the area covered and mapped, it's just it's going to offer so much. And mapping is just becoming more and more critical. In fact, the president signed a memorandum to advance our ocean mapping of the U.S. exclusive economic zone in November of 2019 also, right after that S&T summit. And so that has made mapping a national priority. That memorandum directs us to create a national strategy for ocean mapping and exploration. We've done that. Also, Alaska coastal mapping strategy, and then another effort to improve the permitting for a plan to improve permitting for those kind of activities. When we can accomplish those missions with UASs, I mean, that's just like expanding by an order of magnitude the possibilities for collection. And so it's exciting to see. And it's really important because mapping is just so fundamental to everything we want to do in sustainable use of our oceans. Think about it. It's fisheries, it's tourism and recreation, it's ecological monitoring, for example, HAB forecasting. All of those require really precise maps of the seafloor. And so this is really a terrific example of us meeting that important mandate. Okay, next slide. So at the end of the day, what I kind of, my purpose in developing these strategies, certainly the uncrewed systems area and the UAS of it, was I saw so much good work happening across NOAA. I wanted to better coordinate the collaboration across our line offices, and I also wanted to show the interagency, the White House, and the Hill the leadership that you all are demonstrating in this very important field. It's transformational in nature. We're ahead of the game. We're showing how it's done, and that's going to help us in the future because a big part of the problem is resources. More people, more funding for the projects we want to undertake to meet our mission. And when we show this kind of leadership, the kind of leadership you all are showing at this workshop, that gets noticed, and that will get us the support we need. So thanks for having me. I think we have one more, Chris. And I wish you all the best at this terrific event. I don't know if you want me to stay for questions or if I've overstayed my visit by too much and I have to go. It's up to you.
Thanks so much, Admiral. You covered all the ground that we plan on covering over the series of these workshops in both the training aspects of training, the challenges we have in coastal management, developing our partnerships and strengthening those, and then just and advancing through research and development to meet the requirements for these coastal management challenges. I think we have time for one question if there's one posted in the chat window. Stephanie, have you been monitoring?
I have. So far, I think we've handled most of them. There was a question about whether our NGS data is publicly available, the storm imagery data. I popped the link in there for that.
Oh, thank you, Steph.
Oh, you're welcome. And another question about the requirements for Part 107 for the use of drones, but Justin handled that for us as well.
Okay. Well, that's great. Steph, thanks for fielding those.
If anyone else
Admiral,
has
a
question or two, you can pop it in the chat real quick before the Admiral signs off.
Admiral, once again, thanks so much for taking time out of your busy schedule to join us here. We hope that you'll be able to stay on the line for at least to hear a part of the conversation that's coming today, and maybe check in on the future sessions. If not, I hope you'll check out the recordings and the materials that we'll be providing online. We'll also be generating a report that will highlight some of the outcomes and major accomplishments from this workshop. So thanks again for setting the stage. It really did a great job and shows your leadership in this strategy as well as NOAA's leadership in the UAS field. So thank you so much.
Gladly, Chris. Thank you. Thank you, Steph. And also, let me give a last shout out to Lieutenant Nicole Chappelle. I know she's going to be giving the training piece, and she's with AOC, and I just want to applaud her and our NOAA Corps officers who are really helping make this happen as well. Okay, well, have a great day, everyone. And again, thanks for allowing me to join you.
Thanks, sir.
Well, thank you so much, Chris, and thank you, Admiral Gallaudet, for that awesome welcome. We appreciate your support of our Drones in the Coastal Zone program. So good morning, everyone. My name is Whitney Jenkins. I'm the Coastal Training Program Coordinator for the North Carolina National Estuarine Research Reserve, and I am your facilitator today for our first Drones in the Coastal Zone virtual session. I'd like to give a big shout out to all of our sponsors for helping make today and all the sessions possible. Also, I would like to give a big thank you to our Drones in the Coastal Zone planning team. This includes Abby Wakely and Deborah Hernandez from Socorro, Stephanie Robinson, Chris Taylor, and John McCombs from NOAA, Dave Johnston and Justin Ridge from Duke University, and Caitlin Dietz and Scott Eastman from the GTM National Estuarine Research Reserve. So if you're ever interested in planning a 3-day in-person workshop down to the tiniest detail, then scrapping all of those plans because of a global pandemic, to rework your agenda into a series of 6 virtual sessions, this is the group of people to do it with. What a fun and professional group of people to work with. So thank you so much, planning team. And as you know, this virtual environment is not an ideal way to host this Drones in the Coastal Zone event. We really wish we could all be together in Beaufort, North Carolina. But please know that we have been putting a lot of time into planning these sessions. So if something should go wrong, it is not for a lack of planning. So thank you in advance for your patience and contributions to these sessions over the next 3 weeks. I'm going to turn it over to Steph Robinson, who's going to walk us through the technology aspect of the Adobe Connect platform.
Good morning, everyone. This is Stephanie Robinson with NOAA's Office for Coastal Management. I'm also the National Estuarine Research Reserve Liaison for all of the reserves here in the Southeast. So I see a lot of familiar names in the attendees list today. I'm going to also be running the technology for today's series. So I'm going to give you a quick overview of the various options you have available in Adobe Connect to interact with us today. This is just a quick overview of the layout that you have, and I'm going to point out a few of the pods. First is the attendee list, highlighted here in red, that you can scroll through to see who else is on today. Second is the chat, which is right underneath that, and I want you to notice that the default setting is that your chat is visible to everyone. So if you are having some sort of technology issue, you can send a private chat to either myself or my colleague Kristen Ransom by sending a note to hosts, a chat to hosts, or you can send a private chat to someone in the attendee list by hovering over their name in the attendee list and clicking on the private chat option. The slides are visible in the shared pod here. If you ever want to see that larger so that you can see small text better, you can click on the buttons up at the top and you can expand to full screen. When you do that, you will lose access to the attendees pod, the chat pod, polls that may be open, and other content in the meeting. If you want to get back to the default view, you simply press the escape button on your keyboard and that will take you right back to the normal layout. Finally, we will have some other content available from time to time, such as web links, polls, and other files for download at times, so be sure to look for those and take advantage of them if you'd like. I do want to remind everyone that our participants do not have access to microphones today. That's just to cut down on the bandwidth that's necessary for the virtual meeting and provide a better and smoother experience for everyone. But we do encourage you to please connect with us and ask questions and make comments through the chat. And with that, I will hand it back over to Whitney.
Thank you, Steph. So I just want to point out that we have added some session materials that support all of the sessions you'll be hearing about. And so here's a list of those. They correspond with today's virtual session, Thursday, October 22nd session, and Thursday, October 29th session. And if you look in the bottom right corner, you'll see a link there, Drones in the Coastal Zone workshop page. All of these materials are linked there, and so please check those out. There's some awesome things that the Duke Lab has put together for us. All right, let's review our agenda for today. Shortly, we'll hear about the 5 qualities that drones provide, followed by a Q&A session. As Steph mentioned, I think she mentioned we'll be facilitating the Q&A session through questions through the chat box, like you've already been doing through Gallaudet's session earlier. And then we will take a virtual coffee break. After that, we'll have 3 lightning talks, followed by a Q&A session. And finally, we'll have an unoccupied aircraft system technology show and tell presented by the Marine Robotics and Remote Sensing Lab at Duke University. Whoops, so with that, I'm going to go ahead and turn it over to Dave Johnston. He's going to talk about the 5 qualities that drones provide: affordability, immediacy, safety, quality, and efficiency. So as Steph is turning our layout over and getting Dave's presentation up, I'm going to introduce Dr. David Johnston. He's an associate professor of the practice of marine conservation and ecology at Duke University and director of the Duke Marine Robotics and Remote Sensing Lab. Dave's research program focuses on the ecology and habitat needs of marine vertebrates in relation to pressing conservation issues such as climate change, habitat loss, ocean noise, incidental mortality, and overharvest. Over to you, Dave.
Thank you. Can everyone hear me okay?
Yes, we can hear you.
Fantastic. And I've got my screen share and hopefully everyone can see that as well.
Yes.
Okay, awesome. Thanks. Well, thank you for the introduction. And I really feel like this presentation that I'm going to give now builds on the introductions and kind of focuses in on some of these really interesting and I do believe transformative qualities that drones bring to marine science and conservation. We're going to hear a lot of good examples through this set of webinars. There's going to be a lot of great information about applications presented. And so in this case, I'm not going to talk so much about science outcomes, but a little bit more about the kinds of qualities that these instruments bring to science in a way that can, make our jobs easier and safer and then essentially improve our science. So I've kind of chosen 5 of these mass nouns to describe what these qualities are, and there may be more, and in some ways they may be connected, but it's a nice way to try and sort of tease them out. So for today, I want to kind of drive home what these 5 qualities are, provide some examples, most of them focused on the coastal zone, but not necessarily all. And then also I want to touch on at the end the caveats, the things that sort of limit our ability to make full use of this technology. And hopefully that's going to help you, for those of you who are attending that maybe are on the fence about drones or are more interested in the reasoning on why you would adopt them, how you could propose to use them to make your jobs better or to improve them in the context of these 5 separate qualities. So when we think about the work that we do, it really comes down to sort of 5 qualities that are important for us. One of them is affordability. The second is immediacy. We can talk a lot about efficiency. Quality has always been a concern, and then finally safety, right? And so I'm going to touch on those in sequence, and then I'll come back with a wrap up on these caveats and try and get at some of the things that are limiting us in our ability to employ this technology to its fullest potential. All right, so when we think about affordability, the standard dictionary definition is inexpensiveness, or the cost or the price of something. And this cartoon gets at an example for doing some work, say, with seals that might be breeding on the sea ice or perhaps on a coastal area, and would be typically conducted via either a helicopter or an occupied fixed-wing aircraft, which can cost lots of money. And we compare that to, a research grade drone that can, high endurance, that could fly for 80 minutes. We're looking at a massive difference in terms of the price, right? $7.5 million to buy a helicopter, $10,000, and a much lower flight cost to be able to support it with the UAS. And we actually have tested that out and found that for SEAL assessments in Canada on the East Coast, we were able to come in at 20% of the cost of what it would have cost had it been done internally by the government agency or by an external contractor, right? So this is a good example of that affordability component, and perhaps most important for groups of people that are interested in becoming more connected to their local context, right? So if you're a First Nations group that has the ability and right to be able to manage your own coastal resources, it's a lot easier to buy some drones than it is to buy a helicopter. And that means that this technology, the affordability of it, can make it a very democratizing sort of situation. So that's just about platforms. So when we can talk about sensors, right now you can go out and buy research grade multispectral cameras for under $6,000 US. These are radiometrically calibrated systems, measure incoming light, produce high resolution imagery, and they can cover bands of light, parts of the electromagnetic spectrum that can match up with what we're doing from satellites, right? And so these instruments are now available at incredibly affordable prices to be able to go out and essentially create, a very, 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 very low Earth orbiting satellite. And do multispectral work, right, which helps us with our vegetation assessments and any number of other applications. Okay, so it's really amazing to see us converge now on a smaller number of instruments that are widely available and very cost effective. All right, I want to now move on and talk a little bit about immediacy. And immediacy is this idea of getting into the action right away, right? To be able to act very quickly, to be able to take advantage of a situation in a science program, right? So this is that quality that involves, essentially being able to jump into a science mission without much delay, right? And so the cartoon here provides an example of us, say working in Alaska or in the Antarctic Peninsula, working from a small boat and being able to go from looking for, say, whales, something that we might be interested in looking at, say, to being able to get an aircraft in the air, fly it, collect the information that we need, all within a very short period of time, right? Sometimes the things that we're interested in aren't always available, right? So we can take advantage of animals that are at the surface at very short periods of time. And it kind of gets at the idea that occupied aircraft require some lead time. And so in the coastal sense, immediacy might be really important for something like an oil spill or stranding of a protected species, group of say things like pilot whales or other animals, right? So there's lots of really amazing sort of reasons why we want to be able to get into the air quickly and collect the information that we need. This really gives you an example of what that looks like. So this is us in a small Zodiac, on the search for whales, and essentially being able to go from that situation to having an aircraft in the air to be able to study those animals within 5 to 10 minutes maximum. Okay, so incredible immediacy in that sense, and that allows us to be able to capture information about organismal behavior that's only present at the surface for a very short period of time, right? So we're able to capture these events, and you probably can already think of examples in the coastal zone that this would relate to. In our case, that allows us to do incredible things like actually measure a blue whale and estimate its mass, and so this kind of gets at observations that we haven't been able to do before, right? So not only are we making things more immediate, but we're actually doing things quickly that we haven't been able to do before in that sort of rapid way. I want to kind of step on now and talk a little bit more about efficiency, right? And this is essentially that kind of ratio about how much work you perform in relationship to how much you expend to try and get that done. And this is a really excellent sort of niche for drones. We know that we can use these aircraft to fly over coastal areas and map them with drones that can fly over an hour, collect information, data at resolutions maybe at 3 centimeters or less per pixel, and to do that very quickly with a very small crew. In contrast, if you were to try and do that same level of habitat mapping, especially three-dimensional mapping with, say, a laser scanner, it would require a larger crew of people and much more time, right, to be able to go and do that. And so this has been demonstrated by a number of authors in the literature that small drones in the coastal zone can actually increase people's efficiency dramatically. If we look at that comparison for a terrestrial laser scanner to build a three-dimensional model of say a beach, if you have a 3-person crew, you can survey in about 4.5 hours, 0.005 kilometers squared of an area, where with a 3-person crew, or perhaps less, in the same amount of time, surveying a lot more. And in fact, we can usually fly 3 or 4 flights over the areas that are being scanned at the same time with a laser scanner, which gives us this incredible efficiency to collect high resolution data. If we think about trying to, say, outline oyster reefs, one of the traditional methods is to take your standard high resolution GPS and walk the perimeters of those reefs and collect that information to estimate how much area. But we can do that now with a drone in a GIS, right, to accurately assess the amount of oyster reef area in a very short period of time. And I think this becomes even more powerful when we think about applying deep learning techniques and artificial intelligence to this. And this is something that we're going to talk about a little bit later on. But incredibly large efficiency gains when it comes to mapping in this mode versus traditional techniques. And we'll talk a little bit more about the quality and safety parts of that as well. There's also other ways that we can use drones. We can use drones to train artificial intelligence models, and we can use them to validate them. And so instead of having to have people go through and actually collect that training or validation information on foot or in traditional modes, we can use drones to go and do that. And in fact, we can cover 20 times the area in less than half the time, right, when it comes to collecting these important data for validation and training of machine learning models. And then doing things like just counting organisms. So counting organisms, in this case, this is an example of sea turtles in Costa Rica, by applying drone technology to fly over that area and a combination of artificial intelligence had us at the point where we were able to count 8% more turtles with 66 less time of analyst effort, right? So the volume of data that's produced and the rate at which we can actually go through it is key for this sort of sense of efficiency. Now, it doesn't really matter if you're able to do things really quickly if the data aren't as good. And so one thing that we also have been able to establish is that the quality or the standard of those data that were being measured isn't failing. It doesn't decline, or it's not diminished in comparison to what we would collect on the ground. So in this case, we might have an example of someone doing a survey with a very high resolution real-time kinematic post-processing kinematic GPS on a drone to be able to fly and map a certain area and essentially collect data that's within 3 centimeters and 5 centimeters horizontally, in relationship to exactly where those things exist on planet Earth, right? And so this quality doesn't decline as we sort of move towards these new techniques. And I think that's probably one of the most important things that we need to do is actually capture those changes in quality. And so in terms of counting coastal organisms, one of the first things that we did is partnered with NOAA to be able to compare drone-based counts of seals versus what would typically be done with an occupied aircraft. And when we did that, the differences between counts was negligible, and actually drives home this idea that if you wanted to make sure that you maintain a time series, that these types of techniques would allow you to do that without worrying about introducing a large bias in the case of these kinds of colonies and seal counts. So a lot of it helps us build confidence that we're collecting data of similar or higher quality. And the same thing for oyster reefs, right? If we want to go out and make sure that we're assessing the height and the area of oyster reefs, we know that our drones can provide as accurate, if not better, information when trying to estimate the total area of the things that we're interested in, right? So these tools, along with being affordable and efficient and providing that immediacy, we're not sacrificing quality when we move into these types of platforms. Final example I'd like to show there is just some errors that we've assessed when comparing drone-based surveys and structured from ocean beach creation models between a terrestrial laser scanner and what's produced by the drone in both a vegetated area and in an overwash area. And so in this graph, the vertical axis is the actual variation from what was measured in with the GPS. And the two survey methods are listed as TLS and UAS across the bottom. And the two blue circles represent the variance, right? The difference between what was measured by the survey GPS and what was measured in the models. And you can see that the UAS errors are clustered and they're low, below 0.05 meters. Which gives us a lot of confidence that we can take these instruments into management situations and collect accurate data to be able to address things like storm effects on a beach, like what we have right out here outside my office. All right, so last thing I want to talk about is safety, and this is something that often comes up in terms of drones and often in the context of conflicts between occupied aircraft and unoccupied aircraft, or as NOAA is moving along now towards uncrewed aircraft. And so, I think those issues are being dealt with well with integration into the airspace, but there are lots of actual safety gains that we get by reducing the amount of time that you put people in occupied aircraft if you need to. Now, I'm not saying that we're going to get rid of occupied aircraft to do these things, but maybe there are missions where we can. And so, for example, thinking about long-range endurance UAS to be able to go out and do surveys of animals in the ocean, that can help, right? That can reduce the amount of time that people are put in risky situations. And there's only been one paper that has been published on this, and it looked at mortality risk for wildlife biologists up until about the year 2000 and starting in, I think, maybe the 1950s. But at that point in time, it was aviation accidents were amongst the highest reasons for wildlife biology mortality in wildlife biologists. And so this is a really good indication that we can increase safety for people. I love this picture on the right because it sort of defines this difference between having 4 people in a helicopter with cameras versus a small foam airplane flying over a seal colony and collecting good data that can be used for population assessments. And the picture on the left is actually a colleague of mine, Lindsay Young, who frequently uses helicopters to study birds in the mountains of Hawaii. And this is actually her standing beside the helicopter she had been in that suddenly lost power, landed on the mountain, and rolled down the hill. And so I think it really drives home the idea that there is risk associated with these occupied aircraft flights. And yeah, here's the statistics from the SAS paper from 1937 to the year 2000. 66% of those job-related deaths were associated with aviation. So we can do better, right? And I think we already have. I mean, clearly we have a stellar record in many ways, but there's always the opportunity to reduce risk. We can also think about safety for the habitat, right? So on the right-hand side here is a picture from Google Earth that actually shows 2 lines through a marsh that are created by researchers that are continually monitoring these areas. And so in doing their science, they disrupt the actual habitats that they're working on. And so we know that if we can collect similar information, we'll be able to reduce this kind of influence on habitats, right? So in this case, our lab has been working on trying to develop techniques to be able to estimate biomass of marsh grasses that could be useful and maybe reduce the number of times that people have to move through these habitats and disturb them, some of which might be very, very sensitive. And so that's a key component when we think about safety, not just for people, but for the environment, for the things that they're working on. And then finally, one of the things that we can do is use these tools to actually extend safe operations, right? So working with folks at the Palmer Station, the Antarctic Research Station at Palmer Station, as part of the Palmer LTER, it's very difficult to be able to sample close to glacier fronts because of the risk of ice falling. And they're very interested in the temperature of the water in those places. It's actually quite easy for us to be able to fly a drone over those areas and actually map thermally the distribution of ice and water and especially where that warm water plume might be coming from. In this case, in the bottom image there, you can see warm surface water sort of moving across the front of the ice and extending from some source appears to be on the land. And so this actually allows for the first time researchers to be able to collect high resolution information about the surface waters close to the glacier that they haven't been able to do before. And again, to be able to do it quickly, affordably, with high quality and extend those safe operaends, okay?
Hey,
so,
Dave, it's
yes.
a 5 minutes heads up.
Okay, awesome. Yeah, well, I think I'm pretty much close to the end now, I think. And in fact, so it's a good thing now to kind of go, kind of step back from all of these sort of positive ideas and potentials and talk about the things that are stopping us. And I like this cartoon because it captures a lot of the things that we would worry about. We have to think about legal issues. We have to worry about disturbance of organisms, and we have to think about our regulatory environment and whether or not we are, essentially breaking the rules by, say, flying over people, right? The things that we're not allowed to do without waivers from the FAA, at least in the U.S. national airspace. And so when we are contemplating these great qualities of drones, we have to realize that right now this technology is essentially exceeding the limitations of our current regulatory frameworks, right? There's a lot of promise, but a lot of the things that are in our way are not necessarily technological. They're more about, governance systems that haven't been able to necessarily adapt to what's going on, right? And so in our work, thinking about being able to fly at night, the issues about flying over people, and the fact that we can program aircraft that can fly for long distances, but that we have to keep them within visual line of sight, all restrict our operations and things that we could do safely, but they're beyond the regulatory limitations. Right now, you can get waivers, and so we're working through the process to do that. But they have in the past slowed things down, while the technology itself has essentially skyrocketing in terms of capabilities. So we're limited in that sense. And I think, it's not fair to say that we're really at a point where this technology is completely mature, right? We have very little information about mean time between failures of almost every part of a drone. We collect that information for all of our flights and hope to be able to inform, these discussions. But even thinking about battery performance, how long does a propeller last? When should you replace those things? We actually don't have a good idea, in a lot of cases, how long we should wait until we should be swapping parts out, right? The things that make aviation, occupied aviation, so incredibly safe. And then finally, and this is kind of like a combination of the two that I just said, the regulatory limitations and the immaturity of the technology, is that they kind of combine to essentially limit scalability in a lot of ways, right? So because we don't necessarily have a complete understanding of how long an aircraft might fly safely, or its performance over long flights, it's harder to think about scaling those missions up to cover larger spaces or for longer periods of time. And so this sort of immaturity of technology and the regulatory environment essentially limits us in a lot of ways, right? So we may be able to technologically do things. We may have some distrust of the technology, but we know that it can actually do certain things. But both of those essentially limit how well we can expand our operations to be able to make take advantage of how cheap they are, how efficient they can be, the quality of data that they produce, the safety component, and thinking about those next steps where we're able to fly drones beyond protected areas regularly and in a way that's helpful and useful for management purposes. So hopefully through this presentation, kind of driven home the 5 qualities that I think and drones bring to our marine science and conservation programs, and provide you some examples. I think we're overcoming those caveats, and hopefully one of the things that this presentation does is stimulated you to think about how you might want to include these types of systems in your research, and that hopefully the rest of the webinars that you're going to attend will provide examples of those applications, examples of training, the ways to actually move down that pathway and achieve the goals that your programs have to be able to use these tools efficiently and effectively. And so that's all I have. So I will now pass it back, and happy to ask or take any questions.
Thank you, Dave. So if anyone has questions, please feel free to put those in the chat box. Dave, we do have a question from Paul Gator. He asks, do you have training or testing data available that we can use to apply some of our novel, robust algorithms to? We would make them available if they achieve increased performance.
Absolutely. For all of the work that we do, as we're working on particular methods and we publish them, we also publish the code and the data. And so right away, those data sets may be available to you right now. And if they are not, then please feel free to reach out to our lab members and see if we have what you'd be interested in, because we have a lot of data that we would love to share. And our lab has a very strong commitment to open science. And so, yes, we would definitely love to. And we've shared data with other NOAA programs. We know that other government agency programs are using some of our data to be able to train models for other, artificial intelligence models for other types of detections. And we also work with private industry to be able to, help them in their efforts as well. Does that answer the question?
Paul can let us know in the chat if he has some follow-up from that, but thanks for answering. I do see that Pedro is typing in the chat box right now. I'll give him a minute to finish typing to see if he has a question. We do have a few more minutes here in our Q&A. And it looks like he stopped. Oh, got another person typing, so we'll give just a moment while we're waiting for questions to pop up in the chat box for our lightning round speakers, Troy Walton, John Chalice, and Elix Hernandez. If you'll hang around during the break, we'll do an audio check with you.
Dave and colleagues, I also reopened our web links pod. If you want to pop a link in there, you're welcome to do so. Getting to Paul's question.
I have to kind of dig up the DOIs for the data, but it'd probably be easiest if we have an email conversation and sort those things out.
So we do have a question from Pedro.
Sounds great.
Phantom Pro 4 V2 drones to map. When I process a mission, see the image has 4 bands. However, I don't see it to be real. Do you know what's going on?
So, if you're using the Phantom Pro with a standard camera, you're going to have 3 bands. You're going to have RGB, and there may be an alpha channel that might be that 4th band that's represented. I'm not exactly sure how that would work, but if you are able to bring those orthomosaics into NV or ArcGIS, you should be able to tease apart those bands, I do believe.
Great. So I believe it's Danielson has a question. Do you have ways to collaborate or somewhere we can propose collaborations?
We definitely have many collaborations with folks from NOAA and other agencies, and often it's usually focused around identifying a funding instrument that might be available to be able to help support that collaboration. The other thing that we really believe is fundamental is working with students, and often students are these great connectors between research labs and agencies. And so those are 2 ways that I think we have found very successful at building collaborations with both private industry, with other universities and other educational institutions, but also government agencies.
Great. And a question from Hugh. How autonomous are the drones? How much does an operator control them, and how much training does it take to become efficient at doing so?
That's a big question. The simple answer to the autonomy part is that most of them are quite autonomous, and you're able to build flight plans and do some pretty amazing things with the intelligence that's on board the aircraft. Becoming an operator is very multifaceted. Some people are very good at it right away. Some people are more, it takes more time to learn. But I think the first steps are to be sort of getting through the initial certification. So in the US, being able to get your Part 107 as a commercial operator, which is not necessarily something that has to happen within the government agency context, but for us external folks, our missions are commercial. And then I think practicing and getting involved with a local course that may provide you with more background on how aircraft work, the kinds of things to anticipate, and then essentially flying as much as you can.
And I'll also point out that our October 20th webinar is talking about incorporating training into your drone program, and we'll probably go into more detail about some of those issues. And then there are a couple comments again from Danielson about his undergraduate research and using drones. And so Dave, I'll just direct you to those comments in the chat box.
Yeah, I see that. Yeah, Danielson, we would be happy to talk to you more about how we might be able to collaborate both in training and in terms of science applications. And so if possible, we can connect after the meeting or when the webinars are finished, once you've kind of been able to soak in all the stuff that might be presented, and talk about how we can collaborate next if that's something that makes sense for you. Absolutely.
If I could add to that, Whitney, I know we keep in our mind, or we keep in our back pocket the idea to have these in-person sessions that are actually hands-on training demonstrations, and you know, we can't do that now or quite yet, but it's always been in our mind to plan one somewhere in the Caribbean, Puerto Rico, and/or the Virgin Islands. So hopefully we can come in person and check out your ecosystem.
Thank you, Chris. So I'm not seeing any other questions in the chat box. If any others come to mind for Dave, please stick them in there and we will address them as best we can. It is now time for our 5-minute break is up. We are back in and we'll be now moving on to our lightning talks. So first we'll hear from Troy Walton with Atalo LLC about the regional drone demonstration. Then we'll hear from John Chalice from Creighton University about mapping Spartina biomass. And last but not least, we'll hear from Elix Hernandez from the University of Puerto Rico about vegetation cover regeneration after hurricane impacts. Oops, so I don't have my intro slide for Troy, that's okay. So Troy Walton is on camera right now, and oh, there it is, thank you, Steph. Troy is the remote sensing lead for Atalo LLC, a service-disabled veteran-owned small business based in New Bern, North Carolina. He flew UAS for the Marine Corps and is now interested in utilizing drones for the advancement of natural resource management. All yours, Troy.
Excellent. Thank you. Good morning, everyone. As Stephanie just mentioned, I work for a veteran-owned business. We are based in New Bern, North Carolina, just about 45 minutes up the road from Dave and the Duke Marine Lab, and we have strong ties with them as well as a couple other universities that I'll mention here in a few minutes. We all are former aviators of some sort, so we have various backgrounds that you can see here, anything between helicopters, jets, and then we all kind of met at what's called the VMU, the Unoccupied Aircraft Squadron for the Marine Corps. So that's kind of why we were brought in. We specialize in training and even specialize more in operational side of the training. So the main thing that we want to talk about today is READY, or Regional Drone Demonstrations for Installations and Environment, which is DoD military focused. But before that, we got to talk about CONFIRM, which is kind of what got READY sparked. So CONFIRM is Coastal Erosion Fire Management. Huge shout out to Dave for the great naming convention there, CONFIRM. So that is a demonstration only project. We're showcasing that you can use drones to all of the 5 things that Dave just mentioned in his brief earlier to better utilize natural resource managers' time and efficiency. So we have beach erosion and post-storm management after large events, so hurricanes, or they have large amphibious landings on Camp Lejeune, and this one is solely focused at Camp Lejeune here in North Carolina. Then we also did a small portion for controlled burn or wildfire tracking. That kind of stemmed into READY, the regional drone demonstration. We took it from Camp Lejeune and we expanded to Marine Corps Installations East, which is 5 different bases spanning all up and down the East Coast, Marine Corps focused. So one thing to highlight, this is a DoD funded project. So they did give us the money for all of the research that we're doing, and then I'm going to talk a little bit more about what we do specifically at Apollo, but our research team is the Duke Marine Lab, specifically marine robotics and remote sensing portion, and UNC Chapel Hill, we have the Institute for the Environment and Institute for Marine Sciences that we partner with. So for Apollo specifically, we have three main deliverable items. The first one is mission kit delivery. So we were provided the funding in order to deliver a mission kit ready to go to the environmental management divisions of all of the bases that I mentioned. So that includes a few different drones, and I'll show you what those are here in just a minute. But we also have to go through and provide the training to utilize that. So one of the questions that popped up at the end of Dave's brief was, how much training do you need? So as an example, our course is 2 weeks long. It's quite intensive. The first week is heavily focused on classroom portions, and then we get into live flight training as well, which is a requirement per DoD Basic Unmanned Qualification, or BUC Level 2 is what it's formerly known as. And then we also teach to the FAA's Part 107. And our knowledge check at the end of this course is a Part 107 mock exam, essentially. And then lastly is protocol development. Our main objective when we leave this project is to set up the environmental management divisions to run their own program. So that includes a lot of groundwork that we have done in order to get things rolling. So we're providing some protocol documents such as a remote sensing field guide, which basically if they haven't flown in a while, they'll pull open this guide, they can go to the field, and it's kind of a quick start in order to get back into it. We have standard operating procedures, and then cybersecurity, which has been a large portion of this project that we did not anticipate. So I have to mention a few of the hurdles, cybersecurity being the largest one, because when we began Confirm, we were good to fly anything on base, essentially. They came out with the DoD Inspector General, the IG, basically said that there's a lot of cyber breaches with this, and they came out with the COTS UAS ban. So COTS is commercial off the shelf. These are the drones that we were providing to the bases. So you could go out, anybody can purchase these. Some are quite expensive, and then some are quite inexpensive. But it was basically a increased scrutiny on foreign-made drones, and as you can see there, DJI has a heavy play in the market, if you weren't aware of that, at approximately 74%, and it's even higher than that in the commercial grade, which is kind of what our target is. And then obviously I now wear checkered button-up shirts instead of camouflage, so being a civilian trying to influence DoD policy is quite intimidating and quite tough in some aspects. So lastly, here is the kit. We have basically two different drones. On the left there, you'll see the SenseFly EBX. We selected this one because we based our foundation on Duke Marine Lab. They take these drones to Antarctica, up to Nova Scotia, all sorts of areas. It is tried and true, well-tested, durable. It is a high-precision mapping drone, so we can cover approximately 500 acres at 400 feet, which is the FAA maximum allowable altitude per the regulations, and it'll fly for about an hour. When you add in some safety parameters, that is reduced a little bit so that you can land with a safe amount of battery on the backside. But overall, quite remarkable drone. It comes with two sensors. The one on the right you may recognize from Dave's brief. It's the MicaSense Red Edge. It's a 5-band multispectral camera. And then on the left is kind of a 2-in-1. You have a thermal and an RGB, which is kind of like a DSLR standard photographic camera. And just as an example, I'll show you here in a second, we can get to about 2.5 centimeters per pixel when flying at 400 feet, which is pretty remarkable resolution. And then on the right, there's the Aerodynaphy Thermal. It's a rather cheap, but still highly capable drone. Anywhere the normal drone, the normal Anafi is $800, and the Anafi Thermal is about $1,800 because it adds that thermal capability. We use that one for our wildfire tracking, and then it's also capable of mapping with pretty good resolution.
Hey, Troy, one
so
minute.
Okay, great. Just as a brief example here, it's very rudimentary, but on the left you can see a Google Earth image, and then on the right is what I have collected with our Area X camera, which is also a standard RGB flown in the EBX. And then when we zoom in a little bit more, you can see that large drum and the resolution, and I can even zoom in more than this, but the clarity is amazing. This screen probably is not doing it justice, but it is quite remarkable. And just in case you're wondering, up in that top left, that black and white is the ground control point, and that's how we gear up the orthomosaic to actually where it should belong on the Earth, as Dave mentioned as well. And that is all for me, so I'll turn it back over to Whitney. Thank you.
Whitney, I'm not hearing you.
Oh, rookie mistake. I was on mute. Thank you, Troy. And just a reminder, we will be accepting all questions in the chat box and addressing those after the lightning round talks. So our next lightning round speaker is Dr. John Shallis. He is a professor of biology at Creighton University and an adjunct professor of marine science at the University of Georgia. John is a co-PI for the NSF Georgia Coastal Ecosystems Long-Term Ecological Research Study. Since 2002, he has led NOAA and NSF geospatial analyses research projects on temporal and spatial productivity patterns in coastal wetlands, estuaries, and coastal waters using drone, airborne hyperspectral, and Landsat and Sentinel-2 imagery. Over to you, John.
Thank you, Whitney. And hopefully you can all hear me fine. And you're getting a side view because I've got two cameras, but it's okay. So if you could start my first slide.
You have control?
Of that? I guess I have control of that. There we go. So here's my title, and as Whitney said, I'm going to talk about mapping salt marsh biomass. And we work at Sapelo Island, and I'm a member of a large team of researchers in the Georgia Coastal Ecosystems. That's an NSF-funded long-term ecological research project. And I'm going to talk today about using a DJI Matrice 210 as our platform with a 6-band microsense Altum camera. That has one extra band besides the one you've heard about with the red edge. This has a thermal band as well, but I'm not going to show that data today. We've been using especially the red edge band and the red band in a vegetation index to develop a working biomass algorithm. And so in the background here, you can see, just from a Phantom 4 conventional image, an oblique, what we call shell hammock marsh. And this shows the principal foundation species of our East Coast marshes, the marsh cordgrass, Spartina alterniflora. And you can see some richer, higher growth along the creek bank. That is what we call the tall Spartina. And I'll be talking about the growth classes of these in a moment. I want to use this slide to show you some background that was done with satellite imagery. And this is a simplification by binning our data of 284 images taken with Landsat 5 over our research study area in Georgia, and separating into three sets of size classes. Tall is in red, mid, and short form Spartina. And that over that 28-year period, we were able to document with this archival data approximately a 1/3 to almost 39% decline, depending on and the shortgrass system, which is in the high marsh near the marsh border, has the most stress and responds most quickly to stress. We can connect this pattern of decline, which is a very significant for a foundation species, very significant decline, especially occurred starting with a 4-year prolonged drought in the late 1990s into 2000. And after that, we've never fully recovered, although in 2005 and 6, it did come back pretty well. Each of these data points is an annual average of on approximately 10 images per year. And so it's pretty solid data, and we've been able to connect this to the drought events and warmer temperatures. So it does seem to be a climate change signal. We think it may be a transitional state change, but only time will tell. But we have added Landsat 8 data, and we're not showing a recovery to that sort of pre-2000 level at this point. So one question is, what's behind this decline? And we know that there's sort of a general emaciation of our salt marsh plants, i.e. they're getting thinner, shorter when they're under these drought levels. And we know that the proximate stressor correlates well to soil pore water salinity. A modeling group within our project has been able to work with us, and we can show the connections and a seasonality to that. But we also know that there are marsh disturbances occurring at a smaller scale that you can't really see at the landscape scale of Earth observing satellite pixels, like Landsat is 900 square meters. So here are four causes that we're aware of, and there may be some other things, plus it's just general emaciation. But creek head erosion occurs where there's a below ground mud crab that eats the roots of the Spartina, and when the Spartina is stressed, we think it gets more vulnerable to this herbivory, which unanchors the plants, and then they can slump down into the creek, and it's a very discernible pattern when you're on the ground if you can come across it. Easy to find in drones, but not visible in an Earth observing satellite. Another really important process is marsh dieback, a phenomenon that was only really reported in the later 1990s and 2000s that we're aware of, and has gotten a lot of attention, where a snail, a herbivore of the above ground, which normally just grazes on fungi that it farms like a leaf cutter ant on these plants. Actually, when the plants get stressed, we think chemical defenses are compromised, and the herbivory can eat these plants down to no above ground biomass and bare mud, or at least it greatly damages the plants. There's another process called creek bank slumping. We think this is related to higher sea level and storm surge events, including nor'easter events, where the creek bank, the most lush and productive of our Spartina, begins to slump into the creek. All of these processes can create more senescence and death of above ground material. That can be washed out, and then on subsequent tides, especially on storm events, like this is Hurricane Irma's storm surge rack, presents rack, which can literally suffocate the above ground structure and kill plants if it stays there very long. And at this point, this was 20 months, and some of this rack still exists from Irma. So we've now began to use drones that are giving us a good view, a good high level view of at high resolution. So this is our first attempt in a regression where we matched up drone pixels with clip plots, and we had 78 here. I'd be interested to see Dave Johnson's labs, and maybe we can do some collaboration here. Here's a mosaic from July 11, 2019 when we flew. This is the marsh biomass map that we produced from this effort. You can see the color key here, and it captured very well. It's not the greatest R-square, but it's not bad. We can cover about 2/3 of the difference with that regression model. And then I'm going to show you how we've applied that regression model now to, in this case, to another marsh called Dean Creek, and we began this year, and there are 4 monthly flights that show a green up between winter and spring rather nicely. The average condition was 291 grams per meter squared in January, and now 638 grams in May. Then we had a small decrease in June, which we think may be an early summer stress event, and I'll make my case for that. This, by the way, was rescaled to 2 meters to match up with, so we could just eliminate anything but Spartina pixels using a mask created from a colleague's entire Georgia coastal wetland imagery. And there are 33,000 data points in each of these maps. I'm going to move now to...
John, 1 minute heads up.
I've got 2 slides that can do this. So this is a histogram, and I just want to show this is like frequency of different size classes over those 4 periods, and it nicely captures that growth event where you're moving pixels into the larger biomass bins of those 33,000 pixels. But it also shows in June what we think was the start of a decline and loss of some of this biomass. And finally, I want to show you just a scaling situation where my lab is now starting to work with upscaling our drone imagery to match, in this case, Sentinel-2 imagery at 10 meter. And we're getting really good matchups, even though, and here's the color map, but So for this 8-day apart condition, we got 638 grams for the Altum camera and the S2 with the satellite algorithm 703 grams per meter squared. So that's what I wanted to present, and I hope it shows you a good application to a very important condition in salt marshes.
Thank you so much, John. And just a reminder, we'll take questions after our last presentation. Please put those in the chat box. Our last lightning round speaker today is Elix Hernandez. He is a PhD candidate in environmental sciences at the University of Puerto Rico. His research interests include processes and functions of urban coastal wetlands, plant ecophysiology, and remote sensing techniques, specifically the use of unmanned aerial vehicles for wetland management. Over to you, Elix.
Hello, everybody. Like you said, I'm Elix Hernandez. I'm doing my PhD on ecophysiological responses of plants to environmental conditions, and what I'm going to present you is part of what I'm doing. I want to start giving thanks to Hector Ruiz, Jorge Sabater for image collection, of drone image collection of what I'm going to show you. I'm going to be talking about vegetation cover regeneration after Hurricane Maria. We are based on Ciénaga Cucharilla. This is a metropolitan urban wetland. It has a coverage of 500 hectares and is surrounded by urban industrial environment. You can see on your left image how it has changed through the years, and these affect processes and functions in the wetlands. And the wetland itself has a palustrine, estuarine conditions, and it is good for studying because you have a multiple functional groups, plant functional groups. You have mangroves, grasses, shrubs at such a small scale that you can work with them at the same time. Hurricane Maria brought a lot of flooding, storm surges, squalls, substantial treefall, and defoliation. You can see that on the right image. This is from the NOAA storm imagery. And you can see the community all flooded, but also the wetland, the impact on it. So we assessed post-hurricane plant composition with UAV drones. We didn't have, it was a hurricane, we didn't plan for this, but we saw the opportunity. And we got a DJI Phantom 2 and 3 with RGB cameras. And RGB cameras, they don't have the infrared bands, so we use the visible atmospherically resistant index, VARI, which emphasized in the vegetation the visible portion of the spectrum. You can see the formula is using green, red, and blue. And it works for contrasting bands, as you will see now. We took a 2 hectares area, an image. This is the RGB image in 3 different time periods, in April 2019, July, and January 2019. And the original image, you can see the plant cover. And what we did is we divided in 2 layers. Like the red is the bare soil, in contrast to the gray vegetation. This allows us to monitor how much of the vegetation was going on, progressing through the year. And when we applied classifications based on previous classifications and manual classes, we can see the impacts around the wetland and on our classes: emergent wetland, woody vegetation, shrubs, grasses, areas who are under management right now, and water. You can see where it hits the most in here. In April 2018, like trees were most sparse, but you can see the dynamic of it through the wetland. In conclusion, out of 2 hectares area, 0.7 was lost. Most was trees. The largest cover dominant through after hurricane was woody vegetation, grasses, shrubs, and last emergent vegetation. And what we found out is, even though we didn't have at that point the cameras with infrared bands, using that VAR index, we could use good good resolution, but also repetition, monitoring at small scale for wetland management. So I think that's it. Thank you.
Thank you, Elix. So we do have a question in the chat box for John from Krista. I'm interested in the marsh dieback observed in June. What do you suspect was the cause? We had a similar event at a marsh in Charleston this summer, but it only impacted the invasive species, not the Spartina. We suspect a salinity spike.
Okay, can you hear me again real quickly?
Yes.
Kristen, we did see this. I got the sample in late June, and this was a few weeks after it had been flown, but I got out in the same Dean Creek marsh, and we saw more snail herbivory. The densities were up. The upper high marsh was kind of crunchy, like the Battis was really dried. So we do think it was a dry and hot event that was causing the stress, probably soil salinity. So matching what you apparently saw.
And we did have a question also about, for clarification, this is for Troy, are these mission kits specifically designed for DoD, or are they more widely available? And I do believe Troy answered that in the chat box, but if you want to come on microphone and answer that, Troy, you're welcome.
Yeah, so anyone can purchase the drones. They're known as commercial off-the-shelf or COTS. So you can contact SenseFly, Parrot, whoever, to purchase them. Our role was basically to purchase several and then form what we call a mission kit, and then deliver that to each installation gets their own kit.
Great, thanks. And I see Gino is typing. So Gino asks, marsh dieback underway and marsh adjacent to my house. Anyone want to come and map it? I think that's a rhetorical question, but we'll give them your email address, Gino. How about that? So now, for the sake of time, I would like to move on. Our next portion of the agenda, let's see, I've got my slides here, I can move us on, is the Unoccupied Aircraft Systems Technology Show and Tell. And we've got the Duke University Marine Robotics and Remote Sensing Lab on tap to give us a show and tell. So thank you all for being here.
Hey there.
Julian, this is Steph. You and Dave will need to reshare your webcam.
Yeah.
Thanks.
Can you hear us?
Yes, we can hear you.
Excellent.
Yes.
All right. Well, welcome. Thanks. I'm glad to be here. I'm pretty excited. It's nice to be back in our lab space again from being stuck in our spare room for the last 9 months. But yeah, welcome. This is the Duke Marine Robotics and Remote Sensing Lab, or the Mars Lab, as we like to call it. This is one of the first buildings here, actually, on Pipers Island in Beaufort. And it was traditionally a boathouse. About 5 years ago, we got some money from NSF to renovate this facility, put in some computer infrastructure, which is actually up in one of the labs for hurricane preparedness, and buy a suite of aircraft to help us push forward through our program. So here I'm going to go through and just discuss some of the aircraft systems and sensors that we run in the lab, and chat a little bit about those. And I'd welcome any comments or questions in the chat box, and hopefully we've got time to address any of those towards the end of the talk. So first thing I'd like to touch on is we here run about 45 different aircraft within our fleet, and the reason for that, as our program's grown and the science needs have changed, we've had to adapt and change our aircraft to kind of suit those different requirements. The thing I'd like to point out as well is that like buying a new car, there's not going to be one aircraft that's going to fit all of your needs, unfortunately. So we've had to adapt with different types of aircraft to suit different skill requirements, the types of environments that we're working in. Transportation is one of them, and pilot skill level or training requirements. You'll often hear these drones kind of being lumped into a few different categories. So here's a good example. We've got a DJI Mavic Air, something really small. These are the type of aircraft you can buy from Best Buy.
with these, they're pretty much a one-shot wonder. What you buy is what you get. The camera system on it is not interchangeable, so this aircraft obviously can't really be customized. So you've got a consumer-level aircraft. These are kind of very loose terms, obviously. You move up into more of a prosumer level, something like a DJI Phantom. Generally much higher quality sensors on these aircraft. So we're getting more into the realms that we can actually start to do some, some decent science for these types of aircraft. Still relatively affordable and small. And we'll move into some of the other bigger enterprise level aircraft. For me, these more enterprise aircraft are really the aircraft that we've got the ability to be able to interchange sensors on it, so we have some more sensor options, and we can do some more custom integration into the aircraft. So for the likes of the DJI Inspires or the M200, 300 series in the DJI products, there is a range of different camera options that are available off the shelf for these aircraft. They're a quick interchange, and you can then retask that aircraft with doing a different job. As we move into the slightly bigger aircraft again, we've got some of the Freefly Ultra and then some of the bigger DJI aircraft. These ones we have a lot more control over the autopilot, so we can actually start integrating custom sensors within these platforms. So I'm going to get Dave just to pan the camera for me. And Dave and Troy have already touched on some of the changes that are happening within the federal agencies now in terms of concerns over cybersecurity and those kind of considerations. So that has become even more of an important consideration for us when we're selecting a new aircraft system to make sure that we can still do the work in the places that we need to going forward in these slightly uncertain times. So quickly, when we are looking for an aircraft system, our primary focus is on the sensors and the type of data that we want to collect. So for these aircraft systems, we've got a range of different sensors. Some of them you've seen introduced already, from traditional RGB cameras into multispectral, hyperspectral, thermal, those type of imaging systems. So I'm going to quickly go through and just discuss some of the sensors that we have available and that we use on our regular aircraft platforms. If Dave can switch the camera, we'll just go to a different view and hopefully you can see these up close. Can you still hear me okay?
Yes, we can.
No problem. I'll move this microphone a little bit closer and hopefully it'll work better. So, the first cameras, and in our very first drones, we were using modified, off-the-shelf, compact cameras, the likes of this Canon S110. These ones are actually custom integrated into the SenseFly aircraft. You'll see a USB port in here. That enabled the camera to integrate with the aircraft, so you've got control over a lot of the camera settings. But it was just a standard point and shoot. This one in particular is actually a red edge, so it was fitted with a special filter to just collect that red edge band. It meant when we were flying with these cameras that we would have to physically change cameras to look at different bands. So these cameras, fairly good resolution, generally the 12 to 16 megapixel in a reasonable sensor size, and at a cost of about $800, so not hugely expensive. The next, we start getting into the likes of the SenseFly Soda. These cameras were actually specifically designed for drone systems, so we get rid of all the other components on the camera that we don't need to save weight, the battery, the screen, a lot of the other interfaces and controls. So essentially we just have, on this one here, actually a 1-inch sensor with a prime lens on it with all the interfaces that we need to collect some really amazing imagery with these cameras. Super light and, about as you can see, about a GoPro form factor. The next sensors within the SenseFly range, at least, that we use, Troy's spoken about the Area X. So this is a much bigger sensor on this one here, 24 megapixel camera. Sorry about that. Slightly heavier camera, but definitely a considerably sharper image. As we move up into these, we're actually moving from about a $3,000 camera in the Soda up into the $6,000 to $8,000 range for these sensors. But again, fully integrated and actually custom designed for these aircraft. specifically for mapping applications. One really neat addition that SenseFly have actually just brought out is their SOTA 3D. This camera is actually on just a single axis gimbal. The beauty with this is that as the aircraft is flying along, it'll actually take 3 images. So it's taking a nadir image and then 2 oblique images, which you can actually set that pitch angle. The beauty with that is that we found for a lot of mapping applications, we can actually really extend out our flight lines, so we can collect a lot more data in each flight because we're actually taking a slight oblique image and we can still stitch and alter mosaic together. The other benefit is it creates much better and more detailed 3-dimensional models because you're getting those oblique shots as well. Again, it's just a standard SOTA camera in this gimbal payload that's been assembled in there. And these ones here are around the sort of $5,000 mark for that setup. We've also got 2 options within the SenseFly range, a thermal camera, which we've used extensively for a lot of our animal survey work, grey seals and things like that. The latest addition to that in the aircraft is a Duet T, which again is taking the SOTA camera but also pairing it with a FLIR camera as well. So we can get both that thermal and the high resolution RGB imagery in the same flight, which is a really nice advancement on that. And finally, with that range, we can also add in that MicroSense multispectral camera as well as an option. Just on the price range for the Duet T, you're looking at about a $10,000 camera for the setup here. So these are our standard payloads that we can quickly interchange into our off-the-shelf aircraft for those different mission types. The next is, as we've started to move into the more enterprise level aircraft, we start getting into other sensors which we do a little bit more integration. John touched on this MicroSense Ultim, which has multiple bands plus the thermal and 1 sensor. There are some off-the-shelf kits to add these into a number of the DJI platforms. These are specifically designed for custom integration as well, so they're relatively straightforward to integrate into any of these other enterprise sensors. We also have the likes of the FLIR Duo Pro R, which again is a combination RGB and thermal imaging camera. This has a built-in GPS as well, so it's geotagging the images as it flies. And this can be set up on either a custom gimbal or your own gimbal setup. Is quite a nice sensor. So this is able to record live video and stills and mesh those 2 images together as well, should you want to use that for surveillance or finding people and things like that. And finally, in terms of our multispectral or spectral cameras, we've got a Keynote hyperspectral camera here. This is about a $32,000 aircraft. As you can see, it's a much larger camera. It's not something that's going to fit onto most of your prosumer level of aircraft. You need something like the enterprise level aircraft to be able to carry this weight. So it does require a little bit of integration. It's relatively straightforward. The beauty with this one here is that we've got a spectral band from about 500 to 900 nanometers. But it's a 1 megapixel sensor, but we can select within 1,000 selectable bands, and it'll capture nearly 150 bands or frames per second. So with this sensor, we're able to really drill down into specific questions and look at signatures from plants or from the ocean, contamination, all sorts of different different questions can be answered with that type of sensor. But obviously requires a little bit bigger aircraft and significantly higher cost. And the last, I might get Dave to swap cameras again. Okay. And the last is some of our custom sensors that we've set up. So some of the whale imagery that you see behind us, we were using the FreeFly Ultra there. And we built a custom payload to go under that aircraft because it's capable of carrying so much extra weight. We've been able to take advantage of that and actually build some custom sensors to really make the most of the flight time in the environments that we have. So on this payload, for instance, we've got a completely gimbal stabilized payload. So when we're flying over the animals, the camera's held mid-air. We're using a Sony Alpha 5100 camera with a fixed lens on it for taking our RGB imagery, our still imagery. That's coupled with a laser altimeter. So as we're flying over the animals, we're using this laser altimeter to collect our laser altitude information down to an accuracy of several centimeters, and that allows us to calibrate those images to make real-world measurements of those animals. We've also fitted it out with a GoPro, just a standard off-the-shelf GoPro. The beauty of that is that allows us to actually be able to collect some behavioural data while we're flying. So we get a nice wide field of view. We can use that other data for other projects, looking at behavioural things. It also helps with positioning the aircraft over the animals because we can flick between these two video feeds and allows us to move the aircraft over the animal and then flick back to the Sony, and then we get a nice, tight, full-frame image of the animal, so we get the best resolution on the animal possible. And then lastly, we've also added a GoPro 360 camera on here, which gives us the ability to be able to record the entire environment around where we're flying. So not only are we just looking at the target species of animals, we can start actually collecting behavioural data or environmental data about what's going on through the entire scene around the aircraft. So again, a nice addition. It also produces some spectacular, interactive footage that we can use for engaging with students and things like that. As I discussed, we've got our consumer or prosumer level aircraft. In some instances, and if you've got some engineering capabilities, we've actually hacked some of these aircraft to allow us to carry some of these other sensor packages on there. This one we fitted out with a multispectral, a little Sequoia camera, so we can fly this DJI Phantom and collect that multispectral data. The downside with this is they're not particularly well integrated, so you actually have to set the camera up to just trigger to take the images, and the flight planning has to be kind of matched within the software. So it's a good cheap alternative. This setup here, you're talking $1,500 for an aircraft and about $3,500 for the sensor. Is relatively low cost with reasonable quality data and a great student platform that we're happy to let students go out and play with and not worry too much money in the sky there. And a lot of these systems now we can also couple, as Dave explained, with some high precision RTK GPS systems as well. So we've got both ground-based systems that we can use where we can't stream real-time data, and our bigger aircraft here, the likes of the EVX, has RTK capability on there, so we can actually stream those corrections live to the aircraft, and all that metadata that's stamped on the images is RTK corrected down to several centimeters of accuracy, which is a really nice addition. So I'll quickly step back over and just discuss a little bit about some of the aircraft so you can get an idea on size and cost and things like that. First off, we've got the likes of our little Mavic Airs, and Mavic Pros. As you can see, it's a really nice small package. We can get our flight controller in here, aircraft, and a number of batteries, all in a very, very small travel case. Cost-wise on these, sub $1,000 for most of these aircraft systems. Batteries are nice and small. These ones, for those of you that have ever travelled with these drones, there are restrictions with travelling with batteries, LiPo batteries on an aircraft, because they do pose a fire hazard. So with the smaller aircraft, you can hand carry these batteries. As we get up into the bigger aircraft, that poses a bit of a logistical challenge for us, being able to move those batteries around. And that's based on the watt-hours capacity of the battery. At the moment, it's around the 100 watt-hour mark that you can transport with you. So the beauty of these smaller aircraft is obviously you can pack that up, throw that in your carry-on luggage to go and do your field work. So the controllers for these ones are very basic. For the most part, these controllers will take a phone or a small iPad as your screen, your FPV view that you're getting. and a very simple control and interface with that aircraft system. As you move across, camera-wise on these ones here, generally they're boasting quite a high megapixel count for the cameras. A lot of them are designed more for shooting video, so they're well suited to video collection and things like that, but often the quality of the stills leaves a little bit to be desired, as we found in a number of projects. So very good because they're small and they're portable, great for taking that contextual video or maybe some behavioural data. When it comes to mapping, we found those cameras, because of the sensor size, are just so small in them. Generally, those images aren't anywhere near as crisp and clear and produce as good as products as our larger systems. So, as we move into the DJI Phantom, most people will be familiar with these type of aircraft. They brought this out in several variants now, so you can get that either with their standard 20 megapixel camera, again 1-inch sensor on this, so it's a good size sensor. This can also be, comes in a variant with RTK capability if you need that accuracy, and multispectral as well. And these systems here are around the $1,600 to $1,600 for kind of a standard aircraft. The multi-spec RTK is coming in around $6,500 for that. We've got our Inspire, as I discussed earlier on, more capability. The Inspires tended to be kind of replaced a little bit more now with the M200, M300 series, which has got a lot more options in terms of the FLIR kind of cameras, zoom cameras, multispectral options as well. Most of those systems there, you're looking at around about the $6,000 to $10,000, $12,000 mark as you start getting up into those systems there. We've got our free fly. This aircraft system here, you're up in the $12,000, $14,000, $16,000 price mark for these. The beauty with these systems here, these are actually capable of carrying about a 15-pound payload, which is quite significant. The batteries obviously changed, so we're flying a much, much larger, heavier battery pack on these ones here. This one here is nearly 500 watt hours. So this one here we can't travel in an aircraft with, so we have to actually ground ship these batteries. In terms of flight time, this size of battery will give us about half an hour's flight time on that aircraft. Whereas on a fixed-wing aircraft, a tiny little 3-cell 20 watt-hour battery on a fixed wing on one of our EVs will give us a similar flight time at 30 to 40 minutes. So it just shows you the efficiency difference between those aircraft types. The beauty with this system here as well, as we get up into these other aircraft, is a really nice quick release mechanism on the aircraft. So we can just take this aircraft off and then plonk it on top of one of our other payload systems. So really quick and easy to adapt this aircraft system. It'll fly in the rain, it's waterproof, and also work on a boat. So they've specifically designed this aircraft to be able to fly and calibrate specifically on a boat platform, which is one of the major factors for a lot of the work that we do. And most of the other aircraft systems don't cope with very well. And finally, we've got our fixed-wing aircraft here and a couple of variants. The EV's been one of our workhorses, and we've had all 3 generations of these aircraft. The EVX is the latest generation, slightly bigger, but has all of those other payload options. We've got multiple camera sensor options, the 3D camera, high resolution RGB. These aircraft systems are around the $16,000 mark. Basic aircraft is about $9,000 plus the sensor options on it. As I said before, it's RTK. It'll fly for up to 90 minutes if you activate that within the software, and that's just a legal consideration. And it's a really, really simple system in terms of a drop-in payload in the centre. It's just a hand launch, a simple throw it in the air, and then the aircraft will come back down and belly land on the ground beside you. This is about the biggest aircraft that we, in most of the environments that we fly, that we feel comfortable with. And then last but not least, I'll get Dave to spin round. We've got the likes of the Nova This is obviously a much larger aircraft capable of carrying a significantly bigger payload. This was actually ironically bought as a waterproof aircraft, and it's a question that comes up very, very frequently, is why do we not waterproof our aircraft given that we're using them in this marine environment? And we found out with this aircraft, although it was designated as a marine aircraft, we found that most of the time that we landed it in the water, we ended up with a leak in it, and it rendered it inoperable. So unfortunately, we've moved towards a tack of a really strict maintenance regime and battery management, and we waterproof our drones by making sure we keep them out of the water. And that gives us the best possible flight time within these aircraft systems rather than trying to land them on the water. So I think we're probably getting close to time. Is there any questions, any specific questions that anyone has there that they would like to ask or would like any more details on? Perhaps?
Yeah, Julian, you did a great job answering a question about waterproofness from Joe, and he also wants to know, what do you think about the splash line of UAVs?
The one thing that I found, so for a lot of the work that we're doing for, say, our photogrammetry work over the whales when we're launching from small boats, we initially were putting, pool noodle floats on the landing gear of those aircraft for buoyancy. I actually did some tests in my kids' paddling pool at home just to see what would happen if I landed that aircraft on the water. One thing I found is that even in an ice-controlled landing, a huge amount of salt water got sprayed up around the aircraft and the camera. So that's probably going to destroy the aircraft in the first place. The flotation was also down very low, so the center of gravity on the aircraft was high with the battery up, so high up on the airframe. So unless we landed it in a perfectly calm conditions, I figured that there was a really high risk of the aircraft was just going to capsize anyway. Because of that, because of the added weight and the influence of the pool noodles, it actually potentially reduces the aircraft, particularly if there's any wind and things like that. The aircraft's having to fight with that extra resistance against. In terms of those kind of splash drones and those considerations, the one big thing for us is that any of those waterproofing attempts will add weight to the aircraft. And the best thing that you can add to the aircraft is lightness, because that's going to give you the maximum amount of flight time and the maximum amount of usability. Particularly for a lot of the helicopters or the multi-rotors, the flight time is generally relatively short to start with, so getting as much usable flight time to get the work done for us is really critical. And we prefer, rather than trying to add in this waterproofness, we try and get to the aircraft with the best possible flight time and keep it as light as possible and just give ourselves plenty of wiggle room to get that aircraft back. As we found with the Nova, even though the fact that the aircraft was waterproof, things like the motor and that weren't adequately sealed. So every time it landed on the water, it involved actually flushing the motor out with fresh water. It involved actually stripping it down, replacing bearings. It was just, waterproofing an aircraft is actually quite a difficult thing to do effectively without adding a significant amount of weight. The other consideration is the cooling that goes on, because there's quite a bit of heat that is generated both from the battery and the speed controllers and the motors. So you have to adequately allow for that heat dissipation as well, so that you don't run into any issues. And some early issues did end up just catching on fire because they encapsulated all the electronics in that so effectively that it insulated them and they just heated up to the point of failure. So.
Thank you, Julian. And then we do have a couple comments about getting lists of the cameras and the UAVs that you highlighted today. And your ghost self, Julian, who's typing in the chat box, who's actually Dave, responded that he'll provide that. And also, Dion wanted to know about sources that are not Chinese sources. I believe the federal government has a ban on Chinese parts, and so if you could also address that as well in that list, that would be great, and we can follow up with participants. So Julian, thank you so much. That was awesome. I appreciate the time that you and Dave have taken to set up the cameras and your shop to this awesome demonstration, and we look forward to your future demonstrations at our future virtual sessions.
Do some live flying, hopefully.
Oh, that'd be awesome.
All right. Thank you very much.
Thank you.
Thank you.
All right, everyone, we have reached the end of our session today. And if you could please just take a moment, I'm sorry I forgot to officially introduce Julian there. He's quite accomplished. To please take a couple moments to complete our exit surveys about how you felt about this session. And also on the bottom right, please share any suggestions you may have for future Drones in the Coastal Zone virtual sessions, anything we should consider to adapt for our next meeting. And our next virtual session is on Friday, October 16th, and we'll be discussing environmental quality and habitat conditions. And here is our agenda for that session. And thank you for completing the exit polls and for your attention today. I hope you have an awesome rest of your day.